Hello again, Aya. Here's your part 2 assignment. And again, this is what I was meaning by if you can wait just for me to mark the first assignment and then use the feedback that I send you, then you'll be able to incorporate that into your next assignment and you won't lose marks twice for the same mistake. So again, your domain. I want you to write your domain in interval notation, and if you go back to the notes for rational functions part 1, there is a long note there showing you how to use interval notation. So here you want to go from minus infinity up to negative 3/2 union negative 3/2 positive infinity. Okay. Now your x-intercepts, you've got those written correctly as points, which is good. Again, your vertical asymptote should be an equation of a line, not just a number. And so we need to have a vertical asymptote at x equals minus 3/2. And the same thing with the y, with the horizontal asymptote, it has to be y equals 5/2. And you're right, there is no oblique asymptote, and the symmetry is even. Now, for your key points, in the instructions, in the lesson part of this lesson, it talks about picking points that show the bend of your graph. So the bend of your graph, in this case, this graph looks like this and like this. And so in the bend of your graph, what you want to do is highlight this point and this point of your graph. So you want to try to choose values where it's going around that bend so you get a good idea of the shape of the graph with your points. These graphs these points that you chose for the negative area really don't show up on the graph very much. It would be better for you to have chosen points like -7 through -4, and then you'll get a better idea of the shape of the graph. Okay, so here's question 1b, and I won't go through it each time, but again, you've got to write your domain in the interval notation. You need to write your asymptotes as equations. Okay. To find your intercepts, I see you're showing your work there, so that's good. And, okay, so you've got your -1 and 5. Okay, and again with your points, you want to make sure that you're choosing key points that will give you a good picture of what this looks like when it goes around the bend, when it's kind of curving and changing from negative slope to positive slope, or vice versa. Okay, for 1c, again, the same things exactly about your interval notation and the equations of your asymptotes. If you have an oblique asymptote, I'm hoping that you've shown the work here for that. Yes, okay, good. And you've got your work shown for y-intercepts and x-intercepts. Okay, that's great. For question 2, your first question is correct. That's perfect. That fits everything that's described in the question. For 2b, let me just have a look here at the next page and see if there's more to come. Okay, so we have to have the denominator. That's why I was worried. Here's your denominator, and so you can't have any kind of vertical or oblique asymptotes unless we have a denominator. So this one's going to have a vertical asymptote at 1, which is correct, and your oblique asymptote at 2x minus 1. Okay, good. So you have a good understanding of that. All right, so 3a looks good. That's your profit function. You're right that we can't have x equal to 0. And we also wouldn't be able to have any values of x that would give us a profit that was less than 0. For 3c, I think I know what you mean here, but what you've got is different from that. What you want is just to make it 0 equals. If you put AP at 0, you're saying the profit at 0 which really means that you're making x equal to 0, and you've just set up here that we can't do that. And so just make sure that your notation is exactly what you're intending for it to be, okay? So at x equals 1/2 and x equals 2, you should test both of those back in the equation to make sure that you get a profit of 0 for both of those values. And in this case, that's exactly what happens. So both of those will give us a profit of 0. Okay, for the last question, the first one that you've done is correct, that the value of the car as we start out is $21,000. Now, depreciation means that the value of a car goes down over time. So if you do your calculation again and make sure that you're using brackets, you're going to have 42,025 divided by 4.5 for the bottom. And so the answer here should be $9,338.89. The value goes down over the 5 years that the car is being driven, and now is worth just about half of what it was before. And so the answer to question C is that the value of the car decreases or goes down each year. Okay. So again, for 4D, you want to calculate the final value of the car. And there is a point where it just sort of has a limiting value where it stops decreasing, and it's just worth a junk value. And I believe that that value is about $10. And so if you use the formula for really large values of x and see what value that function is approaching, it should be $10. Okay?